Okay, this is the question 11 from your 2018 paper 2, right? This is the topic on circles, right? So they tell you 3 points given A, B, C. Okay, we can plot these 3 points on our y and x axis first very quickly, right? Y and x, right? 1 comma 4 is maybe somewhere here, right? 1 comma 4, this is our point A. B is 9 comma 8. Okay, 9 is somewhere here, 8 might be somewhere here. This is B, right? 9 comma 8, right? And C is 7 comma 12. 7 is somewhere here. Okay, and 12 is somewhere here. Sorry, 12 should be somewhere below. So this is C, 7 comma 12. Right, then we draw our triangle out. Right, because we have these 3 points basically form a triangle. And they tell you that show the angle ABC. Okay, even though I never draw this very like a 90 degree, there is a 90 degrees over here, right? Cos angle ABC. Okay, so some students will think of, it looks like a triangle, I can do a Pythagoras theorem, right? But in reality, actually, you don't need to do that because it's only a 3-mark question. You can see that actually all you need to do to prove that this is 90 degree is to first calculate the gradient of AB. And AB and BC are essentially tangents and normals of each other, right? So let's first calculate the gradients of each other, of AB as well as BC, right? So that gradient of AB is equals to, let me label this as well, 1 comma 4, right? My y1 minus my y2 over my x1 minus my x2. Right, here I get it to be 4 over 8, which is half. Right, then similarly, I'm also going to calculate my gradient of BC, which is essentially again just my y1 minus my y2 over my x1 minus my x2. Simplify this, you'll basically get this to be 4 over -2, -2. And from here, we can actually essentially just prove that your m1 times your m2, which is equals to half times -2, is equals to -1. Therefore, we can show that AB is perpendicular to that of BC. And therefore, angle ABC is equals to 90 degrees. Okay, then the next part they tell you, this is for part 1. Next part they tell you, explain why ABC lies on a circle with AC to be our diameter of circle. Right, so if you see here, if we draw a circle out here, right, circle out here, right, you essentially need to know that this is your angles in the semicircle, right, the property that you learn in your E-math, right, because you can see that triangle ABC forms a 90 degrees where AC is your diameter and angle ABC is 90 degrees. Okay, so how do we phrase that? Well, we can say that from part 1, sorry, triangle ABC is a right angle triangle, right, where ABC lies on the circumference and 90 degrees is formed at angle ABC, right? And this fulfills the criteria of angles in a semicircle. Equals 90 degrees where your AC is the diameter. Okay, so that's how you explain for part 2. Okay, part 3 they tell you find the equation of the circle. Okay, this part is quite simple. We just need to find the midpoint here, right? Because we already tell you that AC is the diameter. So we find the midpoint between A and C. Right, so midpoint would be, you have a coordinate A, which is 1, 4. So for midpoint, we're just going to add up the x coordinates. 1 and 7, we add it up and we divide it by 2. For my y coordinate, similarly 4 and 12, we add it up, divided by 2. Simplify this, you get it to be 8 over 2, we get it to be 4. This is 16 over 2, we get it to be 8. So this is my center of my circle. And from the center of my circle, I can also find my radius. So for my radius, it would just be my length formula of square root, right? We can use the center that we just found, right? So your length formula is your x1 minus x2 square plus your y1 minus y2 square. Right, we solve this, we get it to be 8 minus, okay, I'm going to use 1 and 4. So 8 minus 1 square plus 4 minus 4 square. Okay, and oh sorry, I wrote this wrongly. 8 minus 4 square. Oh sorry, I'm using my x coordinate. Should be 4 minus 1 square plus my 8 minus 4 square. Sorry. Okay, and this just gives me square root 3 square plus 4 square, which I get it to be essentially just 5. So I have my radius to be 5. From this, I can rewrite my equation of my circle. And my equation of my circle is just x minus my center square plus my y minus my center square, and it equals to 5 square, which I rewrite it again, simplifies to just give me equals to 25. And this is my equation of my circle. Okay, so that's how you do part 3. Part 4, they tell you explain why the tangent at B is parallel to the y-axis. Well, if we see the tangent at B, right, B is over here, right? They're asking why is it parallel to the x-axis, y-axis, so why is it parallel to this, right? We first need to be able to establish that our center over here is also 4, 8. So let's label that 4, 8. Right? If we see this coordinate with respect to our B coordinate, you'll see that they actually find it on the same plane, right? Which is our midpoint of M to B. They're actually on the same horizontal line of y equals to 8. You can see this horizontal line of y equals to 8. Right? And since we know that, right, we can essentially first tell them that, okay, for it to be parallel to the y-axis, it will essentially mean that my gradient is undefined. And for my gradient to be undefined, well, you can see that there's a tangent and there's a normal here, right? We can first find the gradient of our normal, which we will get it to be gradient to be 0, right? And from that, you can do the gradient of my tangent, which is just your m1 times m2, and you will show that essentially your gradient is undefined. And since your gradient is undefined, you can prove that it is therefore parallel to the vertical axis. Okay, so let's first find the gradient of our normal, right? So gradient of normal MB is just equals to my y1 minus y2 again. So it's x y1 is 8 minus 8, right? 8 minus 8 over your x1 minus x2 is 9 minus 4. Right? Simplify this, you basically get this to be 0, right? And therefore, the normal, the tangent, using your m1 times m2 equals to -1, right? You'll get the gradient of your normal to be undefined. And since the gradient of my normal is undefined, we can therefore conclude that gradient of my tangent to be undefined, right? And since the gradient of my tangent is undefined, we can therefore conclude that this tangent is a vertical line and therefore parallel to my y-axis. Okay, it's undefined because you can see here, we take -1 divided by 0. You cannot divide anything by 0. So in the end, it's undefined. Okay, so that's how you do part 4. And the very last part for this question, they tell you find the equation of the tangent to the circle at point C. Okay, so we can see at point C over here, right, our gradient, sorry, our tangent will look something like this, right, of which we will first find the, again, gradient of my normal. So my gradient of my normal in this case is the gradient of my line AC, right? So gradient of AC would just be my y1 minus y2. Again, it's my 12 minus 4. So y1 minus y2 over my 7 minus 1. Okay, which you simplify this to give you 12 minus 4 divided by 6. You get your gradient of your normal to be 4 over 3. From this, you can find the gradient of your tangent. Sorry, this is for part 5. Okay, for the gradient of your tangent, it would just be, right, your y1 minus y2. Gradient of your tangent is your m1 times m2 equals to -1. So in order to find my m2, I just take -1 divided by 4 over 3. I get this to be -3 over 4. Once I have the gradient of my tangent, which is y equals to -3 over 4x plus c, all I need to find is what this c value is, of which my gradient of my tangent, right, passes through the coordinate of c. So all I need to do is sub 7, 12 into this equation, find my c value. Right, so 12 equals to -3 over 4 times 7 plus c. Simplify my c value, it will just give me 69 over 4. Okay, and therefore the gradient of your tangent would just be the equation of your tangent would just be y equals to -3 over 4x plus 69 over 4. And this is your answer for the last part of this circles question. Okay, so this is how you do the circles question. The diagram will help you out a lot, so make sure you draw it out. And yeah.